Hello, Chem 1 and 11 students. Welcome to this podcast. And in this podcast, we're going to cover resources and some chapter 3 problems. All right, so we have exam 1 coming up soon. So one of the things is you'll want some resources to study for that. So located in our class e-learning site under resources is an exam. All right, so this is a practice exam. And I have this version has the questions, and then I've highlighted the answers here. There is another version of this which without the answers, and so you have both the questions and then this one which is the answer key. I encourage you to take the exam without looking at the answer key, and that really helps. I had a student recently who said, they could take the practice exam and get 100 3 times over, but then not do very well on the real exam. And so, but however, once we tried to work through some problems, there were some problems which he couldn't really even start. And so I think sometimes knowing the answer can give you a false sense of security and confidence. All right, so take the exam straight up. And then if you happen to notice some deficiencies, then you can work with those. All right, so practice exam there. Certainly there are notes and some other things that we have from class that can help. One of the things that I've been talking to you about recently is using the textbook, whether you have the physical version or the online version. And so this one actually is great for some problems. All right, so recently I've been talking about some problems that we've had and using a lot in the back of the book. All right, but let's take a look at some problems that are within the chapter. All right, so this is problems that are within the chapter example. And these can be helpful. And so in chapter 3, module 3, we're going to look at some things where we do some calculations of atoms and molecules. And so again, thinking about this compound saccharin, which you don't have to know what it is, but it gives you the chemical formula there, tells you how much, even gives you the structure to relate a little bit to chemistry. And then the prompt is, given that saccharin has a molar mass of this, they actually calculate that for you. How many saccharin molecules are around 40 milligrams of saccharin? How many carbon atoms is another one? All right, and so this little reaction, the calculation scheme, is a great way to get this. And so again, remember we have mass, so we can get the mass in moles by using the molar mass. So we can get the moles of that substance, and then we can multiply by Avogadro's number to get the number of molecules, or oftentimes we refer to that as formula units. And that's just what this problem does. It shows you how to take grams using the molar mass that you are given up here. You divide by that, and that cancels out grams, and then we can go from moles to molecules by using Avogadro's number here. And then finally, you get the answer here in terms of number of molecules. One of the other things that this problem does is ask you to determine the number of carbon atoms. You might say, hey, how do we do that? Well, you do have the number of molecules, and you have the formula unit. And for every 1 molecule of saccharin, you have 7 carbon atoms, and they set up a ratio between 7 carbon atoms and 1 molecule of this to end up getting a number of atoms of carbon. And that's great because then you can see how the problem has worked. So this is example 3.8, which is just cut off there. However, if you turn the page, example 3.8 has a check your learning. And this is really good. This is kind of like a your turn that we do in class. And it gives you another problem and then also an answer. So you can check. It doesn't give you the work in between, but it says, hey, how can we get to this problem? Get through this problem. And so we're going to work this one. And again, I've just written this calculation scheme for mass using molar mass to moles. And then from mole or moles using Avogadro's number, we can get formula units, which is molecules or number of carbon atoms. All right, so as we're doing this problem, one of the things that we'll want, of course, is to calculate the molar mass. And it's going to be one of the important things that we'll need to do in this particular problem. All right, and so let's just go about it. So we have there's 4 of those, and then there are 10 hydrogens. So we need to calculate the molar mass, and so then we just bring out our periodic table, right? And so we're going to have 4 carbons, and so we need to write that down. So we have the 12.01, so we get 4 times 12.01, and then we have 10 hydrogens, and hydrogen's 1.008, so 10 times 1.008, and that's to get the total molar mass. So we break out our handy dandy calculator, right? So clear that out, and we have 4 times 12.01. That equals 48.04. And that's going to be grams. And then 10 times 1.208. And again, we get it equals 10.08 grams. And then we add that together, 58.112. And that's the number of grams, and that's the molar mass, right? So that would be the molar mass here, number of grams, and that's per 1 mole. And that's great because in our problem, it gives us the number of grams. So we have the number of grams, so let's just start using that. We have 9.213 grams, and that's of C4H10. And then we multiply by 1 mole over 58.12 grams. And that would allow us to cancel, and we would end up with moles of C4H10. But that's really not what we're after, right? We're really after molecules initially of this, and so we want to multiply by Avogadro's number, and we'll use the number they use, 6.022 times 10 to the 23, and that would be molecules per 1 mole. And so once again, what we can do is we can take 9.213 times 1 if you want to do that, and that will give you, but then we divide by 58.12, right? And that gives us, if we just stop there, that would give us the number of moles, but really remember, we don't want moles, we want molecules, and so we're going to multiply it by 6.022. That's 23. And that equals then 9.545, and then 8 here times 10 to the 22nd molecules of C4H10. If we compare that back to the answer, it's close. They had 9.45 times 10 to the 22nd molecules, which is what we have. We would probably round this to 9.546. All right, so we'd probably argue that they didn't round up, but perhaps somebody just dropped that, or they just rounded that way. All right, so that gives us the number of molecules of C4H10. Now, the second part of the question asks how many hydrogen atoms. All right, so how do we solve this? Well, we start with our 9.545. We'll just use their number times 10 to the 22nd molecules of C4H10. And then what we can do is then multiply that by, we know that 1 molecule of C4H10, right, we're looking for hydrogen atoms, that there are 10 H atoms. So we're going to take our last answer and we're going to multiply it by 10, and that would give us 9.545 times 10 to the 23rd H atoms. How does that compare to what they got? All right, so again, it appears right on the money. Once again, we might argue about this 8. We probably should round that up to 6. But nonetheless, we have that taken care of. All right, and so again, you want to be very comfortable with working within this calculation scheme, going from mass to mole, and then from mole into formula units. And again, the formula units are something like molecules or H atoms, and we're using Avogadro's number to do it. And in this particular case, we're just saying, hey, we know how many molecules of this we have, how many hydrogen atoms might we have there. So that's one of our problems in this chapter 3. Another problem type that we did was working with molarity and dilutions. And so let's just take a look at example 314. And example 314 makes use of moles of solute per liters of solution. And so in this one, it has a 355 milliliter soft drink, has this many moles of sucrose, which is table sugar. Again, just know that it's not as important that you know exactly what sucrose is to be able to calculate using this. And then ask you what's the molar concentration of sucrose in the beverage. All right, so we have moles, that's moles per liter. They put the number of moles here. And then what they do is they take 355 milliliters and they got to convert that to what? Liters. And so they divide by 1,000 milliliters in 1 liter, and they get this particular answer. So that's one way to do it. Let's do your check your learning. It says a tablespoon of sugar contains about 0.01 moles of sucrose, what is the molarity of sucrose if a teaspoon is dissolved in a cup of tea with a volume of 200 milliliters? All right, so once again, one of the key things is that we want to know that molarity is equal to moles of solute, that's per liters of solution. And so we're told in the problem to calculate this, we have 0.1 moles of sucrose, and then 200 milliliters is our volume. And of course, we want, I said molar, this is mole. 200 milliliters. And so then we have 1 liter is equal to 1,000 milliliters. All right, and so we could just do that. So we have, again, 0.01 mole of sucrose. And then 200 divided by 1,000, we can do that in our calculator, or I would do that in our head. And we can do 0.2 liters and then figure out what that is. And so once again, clear this out and do 0.01 divided by 0.2. We get 0.05. And that's going to be molarity of sucrose. And how does that compare to their answer? All right, well, it's right on. All right, so those are a couple problems from chapter 3 using some of the information and problems that are right within the chapter. And so those can actually be very helpful in studying for this. So I encourage you to do several problems in the textbook, both within the chapter, those at the back. Use the practice exam that's online, because we know the exam 1 is coming soon.